Good morning everybody, namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, February 22, 2022, Tuesday 3:34 AM. मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ. आज coordination world, I am saying quality projects works and coordination world, this is major. Then communication network and concrete, civil field engineering, reliable engineers, work contracts, safety, designs, construction methods, claims, organizations, etc. etc. Signals are just down. I don't know what's happening. Something only not satisfactory. You may say, maybe I don't know it's being recorded or not. 3 FPS means 15 or 20 minimum is requirement, only 3 FPS means 00, I can't say. So this is, anyway, let's move further. If it works fine, if it doesn't work, it's fine. My email ID on this, my name board, engineer. This is my ID on yahoo.co.uk. So Suraj_engineer at yahoo.co.uk. This is for you to write to me if you are interested. If you have some interest in my talk or you have to raise some question, you are most welcome. And this is my International Professional Engineer Certification, which is valid for 5 years. And this is Chartered Engineers India Certification. This is issued by Institution of Engineers India on behalf of this country, Bharat, India. I am attached to Civil Engineering Division. And also this is my fellow membership certificate, fellow of Institution of Engineers India, FIE is called. And then you can say here is my file that I am going to discuss with you, name of which file is quality, and other file that is here, this is coordination. And meanwhile I close this FIE certificate and also I close this file C certificate so that I can talk to you in relation to quality and coordination. And before that, I would just reflect to you, just take your attention to title quality projects works. I'm talking of quality on projects works, but quality in general in life is also very important, because projects is a big quality question and life has quality at every step, which you have to understand. And we have to enter into coordination world of coordination, which is really not known to everyone. We sometimes don't even identify, but it happens. Coordination is a kind of friendship with everything. You got my point. You cannot miss it. If you miss it, you miss something. Coordination happens at every step in life, but we don't recognize it. And communication is a part of coordination, and communication is a part of life. Communication happens everywhere, irrespective of coordination exists or doesn't exist. Communication is your mind, it exists in your work, it exists everywhere, but sometimes we don't recognize it, but we do it. And communication network I'm talking, because we know network is very important these days. Every kid knows what is network. Internet, intranet, net within your home. Net means good net or bad net, we can say. It's a net of, we may say it's a net of fraud, it's a net of cheating, it's a net of social service. And likewise it's a concrete, which means it's a material as well as a state of something. A state of being solid, a state of being reliability, a state of being toughness, a state we can say it's something very concrete, something very solid, we can say we can use it in a proper way, we can trust it. It's a solid answer, you can say. And then it's a civil, which means people of country and people of whole world. Civil is a kind of civil, you mean say it is not military one. It is non-military and that's called civil. And field is every field where work is done, life is meant field, every field means field because if you go to fields and go to your fields of crops. Likewise, field is very common. Which field you are working, we ask everybody what's your field of work. And we can say engineering, which is very, very, very gross title. Engineering means use of mind. I believe engineering means use of mind, and if we do not use of mind, what we are doing, why we are doing, what's purpose, where is it, what does it go, what's its goal, what's its quantity, what's its quality, we all consider that into engineering. What's analysis, what is theory, how can you justify something, and how shall you do something, and what's the value of your getting something, what's efficiency in that, what's income and outcome of that, what is input and output of that, as you can say. And that's engineering is vast field and it's incomparable, you can say. It's incomparable, it's not compared to anything. It's engineering, singles are again down. And this is not engineering, singles are not doing well in good engineering, I can say. And reliable engineers, and that's very important point I'm talking, reliable engineers. When we talk of engineers, means we talk of some person who has got good qualification, technical qualification, technocrat, who has full, we can say, reliability, who has full support to think, has got a brain which can think very well. Think in itself doesn't think on some formula, but thinks on to create formula, thinks on to derive formula, generation of formula. And that's what engineering is. Two systems always available in every engineering mathematical related, and that is either you use this formula by derivation or you use this formula by empirical methods. When you use empirical methods, means something is given to us and you can use it. This is based on experience, you'll get answer of this. You have some formula, some parameters required, and when you got parameters put in there and you get some answer, because this formula cannot be derived. It is based on experience we have used and we have fill up this, and you can say it's a kind of empiricalism. And empiricalism, when you know this is a theory, and we can say theory means it is derived one, I can drive it, this is a way to drive it, there is a theory behind this. If I use this theory and you can drive this formula, and you can say, okay, fine, this is our phenomenon of this, and by this, using this phenomenon, you can evolve this and derive this formula is used, and you can say that's not empirical, opposite to empirical. And that's why we say it is in engineering, and when you say reliable means engineer should do all this. Engineer should be reliable means we can trust engineers, and trust doesn't mean emotional trust, it means trust, logical trust. Because this person can understand, this person can do, this can do everything that we require. We are expected to, based on academic qualification, experience that person, and we can say, of course, this person is engineer, this person has mind. That's why it's engineer, not only this person has mind, but also this person uses that mind for work. And that's what we say, this person is engineer, is not an ordinary person, has got some basic qualification of academics and basic qualification of experience. And this person has done this kind of many times, and if has not done that, he will do that. And that's what we say, okay, we can trust this person because this person can do better and better with time. Whatever he does first time, second time is much better than that, and then further much better than that. And then it goes to attainment, and we can say this person has become expert now. So we can say reliable engineers is a requirement. Reliable engineers are in requirement, and because contracts are required, non-contracts are required, supplies are required, everything is required. So we can say contracts are also a significant part of an engineering profession and in life itself. I don't think something moves in life. Anything that doesn't move in life without contracts, and contracts, you have to understand. Contracts is not just a word, it's something that is statutory, it is something that is based on law. Contracts means two persons have to move on the same track. Two persons have to move together to get some goal, and that goal is for both. One is to deliver that goal, and other is to use that goal. And that's what we can say contracts. And work contracts means we do something, somebody is there who expert who can do it. I'm not expert, I cannot do it. I have money to get that work done, so I can pay that money to someone, and I am a part of contract, and that person is a part of contract for that transaction and for that work. I pay for that work, so I am number one, and that person does it for work, that person number two. There are two parties on contract, party one and that person who gives money, and party two is that person who delivers work. So both are on same contract, and that's called contract. It may be work contract, it may be services contract, it may be design contract, it may be supply contract, it may be whatever else. Maintenance contract, delivery contract, sales contract. You have to understand that in context. Every country has different contract laws, but ultimately, or you can say basics is same. One person does something for other person for exchange of something. That something or some money is called consideration. So we have to stay on this. Then we can say safety. Safety is a wide world, gigantic world where nothing is physical but everything is physical. You have to save physical entity of everyone. Everyone should not. You have to protect everyone from damage, from, you can say, injuries, or you can say from fatalities, or from fire, or from thunderstorm, or from whatever is required to be done. Means every person should have good body all time. Of course, persons are tired, they are fatigue, but it should be minimum. The safety goes with health and it goes with environment. So safety is in fact safety. When I say it means safety, health, and environment. And we have been talking about this a long way. And then we come to designs, and we can say designs is something which is applicable everywhere. In your mind it is, you do some work on drawing, you write something, you have to think about that. Thinking gives you writing, and thinking gives you artwork, and artwork is also a kind of design of a mind. But when it is related to some calculation, it's related to some proportioning, or related to some, you can say, to something to be created, and that's called designs. And we can say whole process before signing something. And then it's a construction methods. And construction method means something we have to, a process we have to write, a process we have to work out. This way we are going to do this job. That's called construction procedure or construction methods. And this is on contracts or otherwise, so everywhere it works. And then claims, and claims means something you don't do it for me, but I get it. I claim else has to pay to that one person works according to contract agreement. That's price. But there can be dispute also because of misunderstanding or miscommunication, or you can say both parties have agreed that we will do something, but there is some point where they miss something, and that something can lead to claims by the person or by both person or other person. One person has claimed other person, and that claim is counted in on contracts, and it applies everywhere. And these points of course this talk is very small, only a couple of hours maybe. Talk of construction, we talk of contracts, because without contracts there is little possibility of construction. Signals are gone, 0, but FPS still exists, so I think it shall continue. We have to be very critical about this. Critical about this issue that we cannot ignore. We cannot ignore these topics in this talk or whenever we talk. And that's why I say quality and coordination is some title here. And I always say because quality sleeps or we force it to sleep, it is one and same. Even it cannot sleep itself because it's not entity. It's not an entity. It's a state of something, and we create that state. It is myself who is responsible for bad quality or quality, whatever it is, or it is everyone. When I say myself, means every self. Quality is never automatic. Quality is not something you can catch physically. It is produced. And who is producer? Everybody is producer. And that everybody is responsible for whatever quality one achieves. And that point we have to understand clearly. Whatever we achieve, whatever we do, it should be within limits. And if we do not do within limits, I think we do not do justice to work, and we do not do justice to ourselves. We do not justice to that power who is responsible for everything, and that power is beyond our control. But our work always remains within our control. Everybody has some control on works, and where we fail actually. And when I say get up quality, don't sleep, I mean to say I have to ask myself, get up and don't sleep. One should not sleep all time. I mean sleep physically, but when you are on work, you should not sleep mentally. When I say sleep, means mentally I have to be alert. And if I am not alert, I ignore, I avoid my responsibility. And that's where I say, if I avoid my responsibility, I certainly miss a sequence of requirements, sequence of activities that I have to do. Or I say, I take it for granted and okay, I assume it's okay, it's right. Because you have to do some activity all times, repetitive. And you feel, of course, everybody is human, and because we are human, we get it, okay, leave it. I assume this time it's okay, without even having confirmation and thinking it's okay. And that's, we can say, we should not do. Because, okay, I relax, but quality does not relax. Substance or material or product does not relax. Once it is done, it is done, and it is going to perform that way. We cannot stop it. And if it's done properly in order, it shall perform accordingly. So it's not fault of quality in itself, it's fault of person who handles quality. So that person announces itself that I am sleeping, I have to get up. So when I say get up quality, this means that person has to get up, who person is operating quality or who person operates production. That person should not sleep. This means it's person's responsibility for quality. It's not on its own. And when I say coordination, it is very important part of quality and production. That coordination means just like our you can say breathing system continues. It does not stop. We have to learn lesson from breathing system. How does it work? So we don't have any control on this, but it works without fail. And it's beauty of our life, you can say. Only point we have to learn from ourselves, to learn from nature, and everybody is a part of nature. You think on you breathing, you have been breathing since you were born, and you never experience any time in life that you stop breathing. And in fact, this is automatic coordination of your mind, your body. If breathing stops, what happens? And you can say coordination and communication do mean a kind of breathing in our words. So we have rest system there, we have gap system there, we have intervals there. Even then, we fail to opt to deliver quality because we fail to coordinate at many locations. Sometimes we think, let it happen and see, but that is too much. And we have to befriend if we want to completely do jobs in all respects according to requirement. In that case, because we have to get some target on quantity, we must befriend quality and coordination by heart and by mind, not by heart alone, by mind also. And we can say we are friend, or we can say we are calculated friends, not optional friend. We are calculated and we have certain kinds of binding by our souls, by our efforts, and that is what is meaning of this terminology. And because it is also true that quality cannot be left, or we can say quality you cannot leave, this means I ask myself that I have to stay with quality. Quality cannot leave me. If it leaves me, because I permit it to live, otherwise quality has permanent residence with me. It will not go away if I keep with me. So it's my fault if I cannot hold it. And if I can hold it, it is my destiny. And it's destiny for everyone. And because one's community is engineering, which community as a whole is responsible for production, for processing, for you can say construction, for maintenance, that community means social requirement. You cannot do anything without that community because it has got long accession to social development. This has developed a lot, this shall continue to develop. We have to maintain this system of integrity, and quality is a part of integrity, just like quantity is a part of requirement. Quality is a specific part of requirement. So what we say, we have to establish equality permanently with us, and that means I have to establish, so you have to establish, everybody has to establish, otherwise there is no meaning of quality, etc., and we are wasting our time. And quality engineering and coordination engineering are very important facts here, and we have to be with them, with us, or else we can say it's all you can say futile talk we do here. We have to understand that point clearly in every respect. So we can say quality engineering and coordination engineering, these are not topics, these are not subjects. This is kind of breathing system. If you want, just like I want myself to be quality person, I want to get quality work, I want to do quality job. It's not because I want, it is a requirement, and if I don't do it, I don't have any value. Maybe I can sell my work, I can sell my services, I can sell my product, but my incidental conscious would say, you are not right, mister, you are not right. You have to think, you have to do, you have to use me. If you can't use me, it's not my fault. And then quality becomes not my neighbor, not within me, but it becomes distant from me. And that means I cheat myself, I quit quality, I don't care for this. And that's where profession doesn't allow, engineering doesn't allow. Nobody stops me, but I know that I am a bad guy there. And coordination engineering is very important chapter, very important, not only chapter, it's a book, or not only book, it's whole domain. Coordination is defeated these days, I understand. It's defeated in every sector. You can experience yourself. Maybe you didn't try once and tell me, or tell yourself what you have seen, what you have experienced with. Coordination is a big branch of world. Communication is just a network, but coordination moves on communication itself. Coordination moves on communication, and we know very well. Without coordination, without communication, life becomes sick. You can say quality engineering and coordination engineering. And I use this term engineering not because of my requirement, it's engineering. I could not understand that time when somebody called me, you're a coordination engineer. You're doing coordination engineering, means it was assumed without even title. But title or no title, that's not an issue here. Once you have, means you have. Who can stop you? My point is that. Who can stop you? If I want to do coordination, I can do, nobody will stop me. And if I don't do, then I don't think I am right person. So I can say that coordination is a part of my job, and sometimes I understand late, and that's also a problem. Means being in profession of engineering or in other profession as well, I can say, it's not alone engineering. In every profession, coordination required, F is required, quality is required. Otherwise, you cannot say we can call it profession, or we cannot say that we can call it work. So, my dear friends, this descriptive talk which I am making is not for fun. It's for requirement of life. Maybe sometimes you feel that I am just, because I am fond of talking, I do it. Well, I don't agree with that. Question is not of talking. Question is explanation. Question is thorough understanding. Talking is not a question mark here, because I am not talking personally, and I am not talking for some picture or for some game. We are talking for development. No development can happen, no progress can happen, nothing can be created if we don't do this. Profession is just, a given name. In fact, profession is something else. You mean say, when we say profession, this means a kind of confession, a kind of association, a kind of attachment, a kind of submission. Means profession is not what only dictionary says. We say, I profess this God, I profess this faith. Why do we say that? Or we call professor, who has some knowledge of, advancement, who has studied advanced courses, advanced syllabus, and doesn't mean that syllabus is formal, who has got advanced stamina to think, to confer. And in fact, everybody is professor if you analyze yourself how far you have reached, or what capacity you have developed to reach. And actually at every step in life we do some coordination. Even a kid coordinates, a grown-up child coordinates, but we are professionals. It's our integral duty to coordinate, and that point is important here. And I have been noticing in this era, it's now 2022, and if you take few years back, and I don't know what shall happen in few years coming time, I can say wheels of coordination have broken. Coordination cannot be defined in any sequence or in any sentence. This activity or this continuous activity has to move. If you do not move this activity, of course you can communicate, but that communication has got no meaning, because there is no system of that. These days communications are very powerful. In fact, communication medium is powerful. Rather than you can say what substance you want to travel on, that should travel on communication network. Means I compare two communications now and past. In past, when we did not have any computer system, that communication of course was time consuming, but it was powerful. It was recordable, and today's communication has no strong hold. People communicate excessively, and therefore nothing it is. It is excessive, but excessive means nothing. Because coordination misses. Is missing everywhere, I say, not in engineering profession alone, everywhere it misses. Means it's missing because just like we are recording this or we are writing something, sometimes we write and we don't want to write because it is easy to speak, people think. It's easy to speak and just go away. But we should not forget, I don't mind speaking, we speak. But we should think first. Okay, if we think I'm a very good thinker, I don't need thinking every time. I can improvise. All right, that's true. This means you are an advanced thinker or you are a professional thinker, you can say. But point is, when we talk of coordination, coordination goes back to history or to records. It works in present form and it can take us to on opinion basis to future. The future doesn't stay with us, it has to arrive. But future can be replaced by a term that's called forecast or forevision, and that forevision means combination of current requirement or current state and historical records. We combine these two, which we can say it's a kind of past reference, and these are our lessons learned. And what we did learn, we have to apply in present circumstances, and which can, of course, move itself to future requirements, future presence, or can say future issues. So we have to understand this past, present, and future. As we see, these three time controls help work. This means we have to link axis or we have to link coordinates of past, future, and in between present. Future coordinates can be generated by past and present coordinates and their processing. And you can say this is future, that we expect this may happen, and which sometimes is a forecast, or we can say is forevision, or this is expected graphics. And when I'm talking in this term, this means every engineer should understand, should realize, and particularly I'm pinpointing on engineers because I observe that engineers which community requires top coordination is gone somewhere else. Use of software in designs, use of software in activity is good, but it doesn't mean you have to submit as slaves to these softwares. Softwares are softwares, nobody minds that, nobody objects to that. But we have to use our software, that's number one, our mind, and that means coordination, and then engineering, and then projects, and then public, and of course at last engineers. It's also a stage. When you say coordination, communication is integrated with that. And we say coordination, full of communication, and of course links of communication to each other or tree of communication in sequence. And that all combined coordination and communication. Of course, jury work goes to engineering. And when engineering comes into play, it goes to projects. And when projects come into play, these are given to public. And then, of course, continuity like that. Again, engineers come into play, and we say everything is fine. Though everything may be fine, may not be fine, it depends. And depends again on coordination, and that is samanvay in Hindi or talmel. And we say projects means yojanaएं, and we can say public means sarjan, and engineers means abhyanta, samanvay abhyantrik, coordination engineering, projects means, and engineers of course in public life. What we say, Ultimately, for what? We have one destination, or you can say personality and totality of profession, and that is reliable quality engineering. And of course, we should say otherwise. If we don't write this term quality, even then, engineering indicates that quality is integrated with that. But for purpose of explanation, for purpose of deliberation, we have to use term quality again and again to remind that person who forgets it again and again. The engineers are not required to forget, they are not expected, because engineering means quality work. Engineering doesn't mean work itself as quality work. We can say then reliable quality engineering works deliveries we have to do, and that delivery means it is trustworthy delivery, it's logical delivery, it's a sincere delivery. That's very important point. And if we have to do that, we have to keep calculation everywhere. We have to calculate at every step. We have to compare what was required to be done, what we have achieved or we have done, what work we have done, have we complied with all work requirements, or you may call it quality requirement, or you may call it specification requirement. And that is very important point here that we cannot avoid. And that's why I always say again and again, my concept is a little different, and I will always show some projects, of course, and these projects only for purpose of reference. You can say, remember my time. Remember my time means how we used to work, and that memory is very important for everybody. Everybody has some experience, some time in life, and we have to you can say, think of that in one way or other way, and we have to sometimes remember what we did in our past. And in fact, that is very important. If we do not think on that, I can say that we do not question ourselves. Everybody has a right to question itself, and I always review my work. Sometimes may be missed. And review doesn't mean just to, what happens when my mind remains busy. And I'm telling my mind state, your mind is no different. You have same power of mind. And when you are a busy person or you are in a profession, power of your thinking is always different than a normal person. A normal person means a person who is not in profession or is not busy all the time. That person is busy in a different way, which doesn't have any responsibility. I mean, if you say I'm an engineer, I'm responsible, then you have to think a lot, and when you think a lot, means a lot of memory captures your thinking power, but when it's required, it releases that. So when I think past, I now understand what was difference there. If I compare to what I know now, what I knew that time, there's a lot difference. And maybe everybody makes mistake in life, and I too made mistakes in life, but I don't have any degree of shame onto that mistakes, because mistake is a part of learning, mistake is a part of work. We may say we don't do any errors. That's a fake statement, false statement. Everybody makes error. Even machines can make error. So we should not mind errors as far this can be rectified. I like to say here, referring to this portion of building, this building, and there are many other buildings here as well. There are buildings here and here. I'm just concentrating on this building, and this is not just because I want to concentrate. So I was involved in this building construction. I was in this was press complex building, press Dar Thawra press complex building. It's located in Iraq, Baghdad, central Baghdad. There was here is a conference palace, in this portion, which is called Qasr Mutamarat in Arabic, conference palace, and this is whole you can say here press complex And I was here for about 1 year on this. I think so 1982, I joined in January in one organization, small organization, it was called by name, it was named as Eurotech and Associates. I was very new in engineering. It was 82 and I passed my degree in 1980 and my civil engineering diploma in 1974. I consider period of this 74 to 1980 a something different time because I worked with government organization. But anyway, that's different. But I'm talking of this. You can see this is tower. This is fourth floor terrace here, and tower started from here. Though it started from down, but we took over from here. And here is, lift and lift here. Stair this side here on this side. And this was a good project at that time in 82. Of course, I was young that time. I was second assignment I had in Iraq. My first assignment was with Ansuls, that was for Sharkat project, Sharkat grain silos near Mosul. I worked on that project for 6 months as first assignment of my overseas. I worked on this second assignment and I was given charge of tower portion framework, concrete framework, means doing with about few hundred people. I can say maybe more than 300 or 400 people. We used to do form work, steel work and concreting work for this tower along with finishes of all other buildings and this building as well. Was not main contractor there. I was with a kind of subcontract representative, and it was of course first big work for me in structures. And I didn't know anything about that, how to do it. I mean, theory we know, everything we know, but how to do it, how to work out physically, I had full conception, and I used that conception and was successful in that. Form work of first setting out, and then form work fabrication, form work erection, steel fabrication, steel erection, and then concreting. And in between all this were at various stages inspections to be done by government representatives or government engineers, and of course our own inspections. I did not even imagine that we would face so many troubles here. I'm talking of 1980 to think of. That time engineering was also not yet advanced. Our concreting was a very significant item on this project. Fair face, and you know what is fair face. Fair face is its face shall not be covered with plaster. It shall stay as it is opened out. There should be no defect on surface, no defect at all. There should be no opening, there should be no out of line, horizontally or vertically in both aspects. There should be no out of tolerance admission. And this is because fair face, it was very important concrete, very important in the sense that it should be accurate. Very, very little tolerance, you can say. If I ask you that this is a column 4 meter high, 4 meter high, you have to pour one time. It's a question mark, and in those days it was also a question mark. Even today I don't see people do work on that. Despite all machines are available or facilities are available. But in those days, if you go back to that 35 years back, 82, around 35 to 38 years, also didn't have that facilities, but because it was Iraq, we had certain equipment, advanced equipments like concrete pump, a reciprocating pump, mobile pump, batching plant, and likewise whatever else, even there was some chemicals and mixtures to be added to concrete. And I never had any experience about this, but it was not big problem because we are subcontractors and it was already there. Every facility existed. They had batching plant, they have all designs and everything. Our main job was doing RCC formwork. I mean RCC framework we have to construct, and then there are three or four buildings where block work we had to do, block work and RCC. I mean block work and plastering and other items we had to carry out whatever were given by them. They used to give us all material and we used to work based on our own people and our technology and their technology. It was an interesting one for me. Why I'm trying to bring to you this is about RCC slab system. That time it was cast in situ, no precasting, and only point of importance here is speed on this project, speed of concrete as well as quality controls, we can say, because in those days there was no written system of quality, and quality means, and moreover this was fair phase, which is very difficult work. There should be no gap in quality. And why I am referring to is casting 4-meter columns in one time means here people don't cast more than 1.5 meter maximum they cast, but casting 4 meters in one go and controlling verticality as well as horizontality, controlling that sides should not open because formwork, wooden formwork or ply formwork, it should not open. And that's where we had to work hard and we had to learn. In fact, we learned. And there's another requirement that your slab should be, whole slab should be repeated in 21 days time. And this was also a challenge. Means you have to do formwork, you have to do steel fixing, and you have to do concrete. And it's for columns and for suspended slabs and beams, as well as complicated item of fascia. Fascia means front fascia and side retaining side walls, all around front and rear were fascia and elevations. And this was, you can say, no direct concrete work, and on sides there are walls. So it was time consuming job, but we had to do under force, with force. And I was happy that I was forced to do this work, and it was good for me to learn and to greatly, though I had good control on workers and we did that, but the way they wanted, it caused some problem, but later on everything was streamlined. So what I'm saying is here controls were very, very uneasy, you can say. You have to do 4 meter high columns and not column very small size. Sections were considerable sections, and like you can say, you had to do lot work on them. Sometimes it was star type column, some were L type column or T type column, many types of columns. So formwork were of that nature. You had to do formwork so that this should fit dimensions, and that was really interesting one. They have to fit dimensions there, to dimensions of it. There's no way to go out without that. We can't say this way or that way. So there are so many columns here, so many fascia. Here this fascia is roadsides, here fascia, there fascia, here walls here, and here you can say lift bank here. I think 3 lifts were there, 3 or 4, and something here, stair here. Likewise, you can say a complete structural work, shear walls, or also you can say fascia, lift itself RCC. We don't see here RCC in our country, but it was complete RCC, and reasons for that they wanted blast resistant structure. because of war ongoing between Iraq and Iran in those days. So, and this was just adjacent to Conference Palace, means it's a point of risk. So it was good structure. And I still remember in those days, RCC design was done by working stress methods, and working stress only engineers know it. Means economical design is not but safe design, we can say. Elastic design, we can say. Elastic design means whatever there is force and whatever there is change on dimensions, it is in proportion. It is not, you can say straight line works there, graphics of straight line, and no, you can say non-linear line. Straight line and non-linear line has different approaches. In a straight line system, we can say x and y axis. Its elastic limit is proportional change, and this can be brought back. Proportional change can be brought back to original state, and that's called elastic state of whatever material. You press it, it comes back. Or you can say whatever stress is there, and there is accordingly proportional strain, stress and strain. You know this terminology, and if you don't, I'd like to explain what's that. Stress means we apply some load. We apply some load on some item, some member, and that load causes some pressure on that member. That pressure on that member and that size of member we use for these calculations. So we can say whatever force is applied on whatever square centimeter or meter area, that gives answer to stress. This is P over A, we can say load over area on which is applied, and it gives result of stress. And if that stress is compared to what changes in dimension, for example, we say there is a length and that length changes, or there is area, that area changes to some extent. So we can say if you measure, calculate out that what change is there, what percentage of change is there in comparison to original dimension, it's called strain. So just I'm trying to explain what is stress and strain. This is important. This also applies to life cycle, and we had to do in this slab all these activities in 3 weeks. We should pour concrete fully in that slab and then continue for other one, and 21-day cycle was very important, though it's very tough. We had to work long hours, and I still remember I enjoyed this. Of course, I was defamed due to 2 errors, one on column and one on walls, RCC walls. And I was stupid, in fact, I can say. Too honest and too sincere. It's not my error personally, but it was error on site, so I was responsible. And due to that error, we had to take out one RCC column duly cast. We had to take out that column. And in one wall also this happened, and both were columns. Error was that it was error or mislocated. It was mislocated, and which was discovered post concrete. It's a very important point that in those days this project was very important one, and I think in Iraq itself supervision was very tough, and that was the duty of Iraq. And I still remember, I respect that. I respect Iraqi culture of engineering, that these people used to employ female engineers, female educated engineers, who used to come to check work, and even if female engineers were there was no difference in checking. As I can just advise you, means in 4-meter height columns, 3 millimeter was allowed if there's some change locally on plumb bob should not be more than 3 meters out in 4 mm, 3 millimeter out in 4000 mm casting. You can say that 4 millimeter maximum in some case. So you can say 1 in 1000 mm. plumb tolerance, 1 in 1000 mm. And 1 mm is very, very, you can't even if you put a split table on that, you won't notice that one. Well, and not only plumb was an issue, dimensions as well as you can say spacing is also having same problem. We have to check everything manually from center to center on this grid or that grid, both grids. We have to make sure and that you have to control from axis of building. Given axis of building, we have to control that one. So we learned a lesson that I thought is easy, is not difficult, but when our first work of 4 columns was inspected or checked by that old person, the one not engineer but good experienced person, and he rejected our work because we did not know how to satisfy this people. Because language was a problem, so in its own language, he required something and we didn't make understand. We did that. Well, I'm just trying to say how we did that is engineering part, not coordination part, but we had to check all these dimensions of columns, or not only columns but all other items, go beams and slabs, from one grid axis on both sides, x y axis, and then we say from that we used to measure so that there should be no error on locations as it happened in one case. We did that successfully, and once we got streamlined, it doesn't become means until you know what person, but there's no question of the specific checking. Everybody checks center locations of a grids and dimensions of columns of formwork, and of course steel is not involved directly, but we had to fabricate steel to fabricate and deliver, and we had to protect steel from corrosion which can be caused by moisture. So we did that work and we tried a lot, day and night we worked there. I had to remain busy on drawings during night time up to 12 or 11 or 2 o'clock, and then applying that one next time. So it was a kind of good experience and for me, and I was very happy that technical work is done. I was not project manager, but enjoying work is important. Doing work is important. Project manager you become, may not become, that's a different question. But of course, everybody, a child like me, or a grown-up engineer like me, or grown engineer like me, everybody has some dreams that I should get this benefit, that I felt. That's out of question here. What I said, I was good on this project in whatever way. Successfully we did it, and we did many slabs here. Many slabs there. Same way, many lifts, castings, or you can say wall castings, column castings, fair face castings, and you can say you have to be busy. Yes, I kept myself busy, and what we get only we know. What how to handle those people. If we see somewhere I can't handle, that's what is very important point, and we have to be very specific about that. The quality is not that can be spoken and it comes. The quality is not that property that you can get automatically done. If you want to get quality, in this case quality of work was very important, and I used to interact with everyone of our company as our main contractor and government people. We had to do that work. But my problem is even if I work on the contracting company, I can't surrender with the quality. You may have your own company of quality, but my task is different. I have to make sure that quality is achieved. It cannot be taken for granted or can be assumed only. Quality is achieved. It has to be done. So this is a long history of this project. I still remember that time. But its time goes on and on. There was some problem on slab we poured, and it made no sense at that time. We started pouring. We did not, after approval, of course, long approvals and then pour. And I did not notice that there was a problem of sand quantity on batching plant. We were just interested in pouring slab and we started, unfortunately, and there was a problem of sand which remained short. And concrete slab, concrete started on slab. How to do? I can't stop concrete. And I ignored checking means what quantity we had. The batching plant was not my control. The main contest control. My main contest duty was to see whether enough quantity is available. We run here and there the time. Our owner, we house have arranged quantity and we completed that slab. But you see some cracks appear on slab when we saw in morning. Our contractor saw his representative, British representative. What is nonsense? What you are doing this and that? Cause why you think this is not acceptable? This and that. Well, we repaired those cracks. No big deal. It happens because of because of heat, of course. But that weather was not that hot at that time. It is, I think, February month or February, March month. It's cold, not that hot yet. Problem is problem. So I coordinated there with contractors, with that engineer of contractor, with others, government engineers, and of course I was talkative that time. And we were very poor contractor, no facilities there of our own. But work was interesting. I still remember, though I was punished there as well because of one column and one wall problem. But otherwise, we did good job there. About others, I'm just trying to tell about coordination. And coordination, therefore, is very important. And though in this we have responsible for concrete, so we have to give good coordinated concrete. This project is still in my mind, and we were doing lifts, lift walls. As people do not talk of lifts here, they talk of only lift brickwork or block work. But their structure lift was there, and this lift bank walls, I think, were used for purpose of seismic loading also, seismic resistance, forces resistance. And you can say sometimes you remember something you learned very beginning. Somebody you got chance to practically learn that, and that's why I would like to say to engineers to not think that you are born in designs. Don't think that design is a part of engineering and it's not independent. Therefore, everybody has to learn, those who are involved in engineering construction or else. And this still I remember this bank of lifts. I think 3 lifts were there. This was very difficult to make sure that this won't open. So we, of course, inspection was done, and it is got parts, instructions are done, but why it was broken, that is unclear. It was unclear, but we did a lot of work day and night, and we succeeded in many results there. So when I sing this building, I just remind you, take days, night we walked in, then we go to some other else. You can very good project, ethylene plant here, and not actually it's the view I taken from someone. This is not seen directly because it is light time, but this was I got this sketch, however, and this is interesting to see that this was ethylene cracking plant, and I was office engineer for this project, or you can say engineering worker there. You say engineering worker, coordination engineering worker, or office engineering worker, what you call it. This was also an unexpected opportunity to me. unexpected in the sense that I did not even think that I was given that job. It was given to me after by chance, keeping an eye on me by leaders of project. And when I was doing small job there, I was given charge of some foundations to do. Not ordinary foundations, major machine foundations. And these are very important foundations where even big generation rest. So you can say it's that kind of foundation where vibrating equipment has to come to use that foundation, and it's also a very big foundation and not small in comparison to other work. So I have many structures to supervise there, not to supervise but to work for them. This is a big project. I'll come back to this later on. We'll talk of this. The purpose is thought of coordination. Coordination, that is very important one for everybody. And as I say, usually, what we say usually in building world, coordination is very important. And we cannot run from that. And here we say coordination engineering is a must on every project, and that's a fact. That fact cannot be defied with. But we have to move further and further, and that's the main point here, because just sticking at one point cannot help. And I'm not going to beat about bushes, I'm going to talk straight way. And that's deliberations on coordination. When we say coordination, this is something very important. Not only important but also responsibility of engineer. And because coordination is done, everybody cannot do it. Those who have good writing power, who have good speak power, and who can write better than others. We have to be very clear about this point. Why I'm talking of coordination, as it's a missing one. I say coordination is not visible. People are working for coordination. Maybe some do use them secretly, but I could not find state of coordination here for many, many years. That's where we have to rethink, I can say. It's not only to engineers but also all the communities like administration, country, and various other rules and regulations we have to consider in coordination. As we say, we have to understand coordination first, and there is no doubt on that. If you don't understand, this means we cannot do it. That's also true. And if you understand, trying to reflect meaning of coordination also in design work and construction work, and that is very significant one. It's not easy that everybody can understand, but everybody has to think of how to enrich that area where have to use that coordination. Coordination is coordinator has got many links. We have to understand meaning of coordination in a true sense. It's that is very light, important light. As we held there yesterday night, that about coordination, point number 24 here. Coordination, we agreed, or we inferred, you can say, if not agreed, because I can't force you, I can't assume you agreed or do not agree. That's your way. You have to tell us that you did that in agreement with the client. When we do something important correctly, rightly, in processor, and we think that we feel happy that I did this work, and this work has been done successfully, and it's useful for you people, we say to everybody, but they don't make anything. When we talk of coordination, we have some problems, we have some issues, or we have some incomplete picture which we have to produce based on these coordination parameters. And that's very important point. And in construction, you can simply say it starts with coordination, it moves in coordination, it goes in coordination. Coordination, you can simply define that you must be ready with all information necessary for some work. And that's what you have to think about. My thinking shall not work here. You have to think your way. Whatever technical information is available or some other information is available, is it adequate or no? Or do you have that knowledge to know which others are not employed with? That we did ballast surface. If you people understand coordination, you can become better engineer, I can say. Better engineer, of course. Because coordination means alive mind, alive actions, non-stoppage except to drink something. Now we are here coordinating with our subject, with our work. This means work should be clear what we have to do. That's first point. You should have potential of its doing and should have certain destination to achieve. Sensations of people. If we miss coordination and we just follow what is given, this is child work. Engineer means a coordinator. Even if work in design or if work on sites, if you are coordinator, you are engineer. Otherwise, you are not engineer. You are just a child, you are just a young man. That's it. We should keep in mind that we can start something and we can end that work. But coordination has no definition of length. It continues all time. So we have to be very serious about coordination, involvement in construction work or everywhere. And therefore I simply say coordination is never ending activity and it cannot be considered as fixed time activity. It is no fixed time activity, it's continuous activity. It is technical and engineering activity, and this activity can be brought to a level from nature to Rome that you can even using manual methods you can chip it out. It's errors by coordination. I want to stress on coordination always because coordination has caused many problems everywhere. Absence of coordination has caused that people do not understand reality. What is coordinated, how it should be respected. People just say it is coordinated well just by intimating others. If you say it is coordinated, it's not coordinated. Coordination is technical process, very much technical process. It's not only doing site, even purchase, you have to take care of this. In whatever equipment you use, you have to take care of this. People just don't care for this, but unfortunately, I'm not talking of common people on grounds, but those people who are in big houses, they should think of all houses. It is everywhere, and coordination is a big subject, you may say. In every theory, in every field, every procedure, it works. It's not automatic, but it works, and it is myself and yourself who operate that, who tries to know what's aspect in this body, how we can think of internally as externally to handle this. That point is really very important, coordination. So we can say coordination is a never-ending activity, which therefore cannot be considered time-fixed activity, but process-fixed activity, process continuity, and it depends on design mandate, scope requirement, along with other contract documents such as engineering design specifications and acquired input from special materials. Producing manufacturers such as documented instructions and material data studies. And we go to further interpretation, can say complexities of technicalities. It's very clear term, complexities, technicalities, complexities of technical work, complex of technical work, and you can say structure of resource. Additional complexities, we have already technical complexities, and then we have structures of resources there in addition to that, which add to our complexity, but we should not worry about that because it can increase flow rate, but ultimately it should be in water. So we have to concentrate on this part of work, very important work. And I always stress on this because I have felt problems in coordination. You may say it's high responsibility, always pays if you consider coordination. Coordination is higher level of responsibility, is always voluminous task, which work imports working knowledge of various engineering processes, and you can say various tasks which work imports working knowledge of various engineering branches and additional branch in-depth knowledge of one's own engineering disciplines. Every discipline is linked on professional basis And it's also true that in current engineering and advanced projects, it is rarely done. If it is done at size, I mean, we can't say it's not done everywhere, but we require, in-depth knowledge. And we say coordination at higher level of responsibility is always voluminous task, which work imports working knowledge of various engineering branches and additional in-depth knowledge of one's own engineering discipline. It's also true. It's also true. It's also true that we can say in current engineering and advanced project scenario, just depending on certain proclaimed software may not be absolutely assistive to automatically resolve details pertinent various conflicts among various disciplines. Therefore, no blind eyes can be allowed to trust outcome of various conflicting details into physically workable solutions. There are various examples we can give in this case from various selections, though it's not exactly, we can just, you can say, we can give certain examples only how works are done, how these were done. It depends on what information we have. I do not find this subject available in free mode. It's not available in free mode everywhere, and that's why we have to find sometimes our own examples only for you can say understanding and comprehend what we talk about. It's very important one. We have to talk about this. Otherwise, it's no meaning at all. And when we say something like that, we have to understand there are so many ways we see. For example, here I'm trying to find something a spool one. I'll just give an example here. Yes, I'll give some examples. I mean, pool one. Okay, I'll come back. Let me see. What I wanted to show you is something different. Not exactly I want to just in there. I'll go back to method statements, and it's of course a very interesting one. If you talk sketches here, and that is there's some. Okay, we have raft excavation. If you see how to do that, it is method statements. All right, let's start with draft excavation here. There's nothing to excel. Let's see, this is that one, and it's there. It's coming out. Now it's a sketch here. You can see this is mass work excavation. This is a building here. So this area is for excavation purpose. Now we have to decide about this, how to do it. Let us say is a procedure, because coordination comes automatically into play. This may be, you can say, good soil, this may be bad soil, it's formation level. And what's formation level? We know that. First formation level, if people do not know, it's very simple level on which we start doing our foundation activities. That's called formation level. Means everything is formed We are ready for foundations. So that's all formation level. But this is a mass, here is a mass, I can say. It's something we can say completely to be occupied or not to be occupied, that's something else. But I'm saying raft now, I'm saying raft means whole area required to be excavated. And for that, what we require, that point we have to understand. What we actually we do, we have to understand that in all respects. Now, it depends on what type of soil it is that we have to ensure, and how to ensure, that's also a thing you can say. We have to enter this area. This means we have to first think of this area. We must have got some information about this area. Otherwise, we cannot do anything. That is one important point. And we can say, if you take another sketch of this, we'll find something else also. Let us say we got another sketch here. And also we confirm this, and we have a different sketch here. I'm just trying to find more sketches on this. And let us say this is sketch here, 3 sketches that we have here. One, and then the sketch. This is also here another one. And let me see, let's give this all right, this one, and we can select this one, and we can select. I just try to bring it in position. Now we have 3 files here. One is this file, another one is this file, and one is this file. He is very, so it's a trench of 1 footing. You can say it's a trench of 1 footing, and this sketch shows those various arrangements of that. That's one part, but we have to excavate this. Before this, we have to coordinate these dimensions. We have to coordinate these dimensions with requirements before going on to work. We should know complete implication, what it can cause. We cannot simply say, I take excavator, go to site and start excavating. That's not the right way. That's not right way, in fact. I have to do study, I have to conduct a study. I have to get information, if it applies, of everything in coordination, and that is, in case there are some underground services, I should not damage those services. And if I am not given information, or this site is not new or well built up or well developed, in that case, underground services locations, if there are, if they are not, that can be known later on also. Let's assume there's nothing there. Services free, strata below. In that case, what we have to think of? That point is a requirement, and it's a beautiful requirement. It cannot be taken for granted, If we have to excavate, okay, if the point lies that the services are running below, it can be anywhere, It can be located in whatever area. We have to excavate 1 footing or trench in pits, you can say, trench in pits, trench in foundations, we have to excavate. In that case, we have to think how to do it, how to do it fast. Is level okay or not okay? Are sides okay or not okay? Or can we keep with minimum time and minimum expenses? Or you just think of expenses, don't think of expenses first, think of ease of working. Because it's engineering, it's construction, and we should know what is strata below. And we have to know this through coordination. If you have soil report with us, and maybe particularly in this area, if you have soil report, then soil report from whatever laboratory it is requires to be understood, required to be worked out. And if you have services, we have to coordinate with required departments, necessary departments, or if you have not had drawings, we have to ask for drawings. And I'm sure nobody shall give you drawings because nobody has got that. Then we have to write to opinion. Oh, this is So after doing check on layout, check on substrata, and you can say when we think that soil is good or it's rock, there's no major issue of dropping, and we don't have any issue for electric supply from government because we don't have account. And we must say that it's something professional, very professional. We have to understand sequence, and we have to understand everything, and we have to take care of safety, health and environment of people, and then its sizes, its depth or levels control before doing all that, and how many foundations we should take up once. It's in sketch shown one, this only for dissemination of information, but practically speaking we never do one single foundation one time. That point also we have to keep in mind. You cannot do one foundation, because if a new engineer says I will do this first and next, no, it's not going to happen. We never do like this. We calculate total number of foundations. If it's really food based or oil based. So this unknown which we have and how many footings we can do, it depends on our calculations. It depends on ease of sight. It depends on how we want to move. It's not simple in just go we can do it. We have to think about how is access to site, can we handle that, or can we do one foundation, can we get that much concrete, and it's not convenient. We have to think on. It is work coordination. It is technical coordination. It is supply coordination. Or you can say it is coordination in coordination. It is coordination in coordination itself. Sometimes activities cannot be taken for granted. Work sequence is important, and sometimes if this area is not well developed, let us say soil is bad, then we have to think of how to improve it if it's not a part of design. If it's given in design, then we have to understand improvement means what is area, what is bearing capacity that is expected, how much it should be, what designer has considered, and is there given some method of improvement, or we have to decide ourselves. Just fill a specification is given that soil improvement is required, but nothing is given in that regard, in fact. So we have to think of all this. We have to, of course, these are other requirements for safety and for others. I'm not talking of those are also part of quality controls, quality methods. that we have to write in that. But here talking of coordination, there should be coordination of all such safety, quality, and construction methods. Coordination should be everywhere. And for example, here is safety. We have to use one metallic ladder here because foundation is not more than 2 meter deep or 1.5 meter deep. We have to use ladder in this trench once it is excavated, and also we have to barricade this around for safety, like as you can see in this sketch, trench excavation, and it's of course safety. That's what we see. So it depends on, let us decide, okay, we use 15 foundations one time, or 50% foundations one time, or we use 4 footings only, or we have to use once. There may be one case, sometimes you have only 1 footing left due to whatever reason. So that's what we say, how we have to coordinate with each other, and how we have to coordinate with services that are to be removed or that are to be inserted. We can say it's very important matter. We have to see existing levels, and we have to see what a force, you can say design levels, and if soil improvement is required, how we have to do this. Do we have good soil for filling? That we have to understand. Or where it is, if that good soil, what results it will give. Have we got samples submitted or approved? That imported soil we have to bring, we have to procure. And is that soil okay? Is that fill which we are importing okay, or that has to be designed again? That has to be mixed with some other material, for example, say dune sand. And then we have to create a cohesive mix or adhesive mix or a matrix of mix that can after compaction compaction is done. It doesn't require any long-term consolidation. Immediate compaction would do better than long-term. And in that case, we can say all these points we have to consider. Into our minds, we can do it only when we have to coordinate documents, contract documents of designs. Both documents actually speak about, and some decision has been left to us, or because designer is not on site, some information only we know, or we can send that information to that also to decide what we have to do. Both possibilities are there, and both required strength of coordination. We have to do the strength what we have to do. And then it is another example. It's also very different one. In this we say there's a continuity of foundations here. Is of course that's a building project, and we have to decide to provide these types of beams around for foundations. Let's say here, wherever you can see this foundation layout comes, and we don't want to excavate this portion. We want to leave it as it is, so that we do not want to do unnecessary backfill. And it doesn't matter, means as far as we are successful, we can decide properly how to move in this area, and we have access from, let us say, all 4 sides. Let us assume we have access from all 4 sides, so there may not be issue of any heavy machine movement or concrete transit movement, transit mixers movement or concrete pump movement, or whatever else we have. That movement is not adversely impacted upon. That we have to make sure. And coordination says that you have to discuss, you have to refer to documents, you have to refer to, if there is a particular customized specification for this, or it's a part of specific general specifications, or you can say project specifications, we have to keep that, and how best we can do this, what depth it is. Let us say here it's written 2000 into 3000. 3000 is depth, 2 to 3000. If that is the this question is, it's quite deep, and how we can go? Can we maintain depth? Let us say it's rock area. Okay, it should be better if it's rock, but question is that soil only, clay soil example. In that case, this is very difficult. The point is, how we have to do this without knowing, and we have gone to soil report, and soil report tells us There's a water strata here in this stage, and then another step you have to take. You have to coordinate about that, and you have to make sure on site what available, not available, and if it's available, why you did not study this report long back? Why it's been there for many years? Survey was done and still not commissioned to start. This means we did not think of this before. We did not have any coordination on this project. And coordination is really question mark everywhere. Can't do. We can't do without that. Coordination is that requirement. It's all work coordination we are talking. It's not simply illogical coordination, we can say. We are talking here. We have to move around this area safely. Let us see. And we have to, all these four corners free, we have to make sure how we are going to do this. We have to handle equipment here in this area. We may have to install tower crane somewhere, if tower crane is good for this. We may have to install two tower cranes diagonally so that these don't strike also. And maybe these are different levels, but the question is that if we can do this. These points are very clear from work point of view, coordinating work to requirement, and we don't want congestion on site also, because people should feel free in construction. Area should be kept tidy, and it can be kept tidy only when we have adopted some system of how to do this engineering, how to interrelate whatever we have. We have some designs with us. We have architectural designs, structural designs here, and we also have, we can say, services designs or other designs, or various directions or notes given on drawings, what we should consider or what we should not consider, or what we have to do, what we think. This may be available, and we have to require it. We have to do it. It's not simply speaking, I will do it. We have to do it. And also, if we take like this, another sketch as well, which is of course little different than previous one. It doesn't have any middle beams, but it has continuous formation in the whole area of excavated trench. We then call it generally now. Again, we have to see, refer to soil investigation report, or we have to refer to soil. This services drawings, if there are drawings available, and if not available, we can ask department whether they have got these drawings, this area. If then when we jump onto this site and see soil is a problem, it's not hard rock. Water table is a question mark, because report says something and something is different on site. Our reports say one thing, and area is one, or we remove whole area so that occupation is once. This is where we have to link ourselves, we have to think ourselves, we have to station ourselves. Means whole mass excavation is done. Likewise, it was done with one trench. It was only not mass excavation, only small excavation. Here's a vast area, so we can allow our trucks to come in, machines to come in into this trench. Nobody shall mind that as far as we pay him. quality bias. In that case, what to do? And say in this case, when it's complete raft, you can say it's go down below and maybe many meters. Many meters it's go. I'm not specifying clearly what it is, but let us say 3 meters it is in this section. You can see this section 3 meters deep, which is quite considerable. And we can consider vertical completely if it is retainable soil. It doesn't give any angle of repose, or it doesn't, you can say, subside. There are certain kinds of soils that can stand like this. And we have to keep in mind that there is no surrounding structure, it's free of that. Means your wall does not rest on other walls should not be with you. We should reach this solution. This access we have to make, and we have to know nature of soil. This is a part of coordination. From report we have to understand what soil is and what we think expectation from this viewer or quotient. We have to keep in mind how do we have to move in this deep foundation, and in case water table is also high. So question comes in, if a report is bad, how to do it? Or there is no need of soil improvement, fine, we can continue without that, but we have to establish bearing capacity. That's only one way, that this is bearing capacity and this was given in designs, but designs could not guarantee. It's clearly written in documents that we have to make sure that we got bearing capacity in this range. That's why we can say we have to think many times about every activity, whether we have to use the watering system or we have to go without that, or whether we have to improve soil or we have to go without that, or we have to, of course, barricading around is a must from viewpoint of safety, and the radars flying forward. Yes. Means once we understand what we have to do, then process is not a big one. We have to decide what method. We have to decide in just maybe in 1 hour, 2 hour, one go. Depending, but we have to know nature of soil first. That's important. If you don't know, if you don't have any soil report, we have to excavate some portion of one column, connect with other column. What does this says? We should not forget that we cannot take for granted all this. We cannot take for granted. And we have to enter into this area. All trucks, all vehicles relevant to this portion must be able to use this area physically. And because of health reason, everybody is not strong. There should be an old age. These examples I am giving you are something different. We have to start something new. We have to start how to do. I'm just closing this now. We'll discuss later on, because it's not simply we can understand everything in one go. We have to move on coordination. The purpose was to show you something in relation to that one. That's an important point of view, and I think we have to see that all these points in immense way. I'm feeling cold again. I think temperature falls. Let me see again for your reference also. We can say it is here now. It's about again it's saying 15 degrees. I don't believe it, because it's 8 degrees dew point. 19 kilometers indicating wind gust and humidity 61%. And I'm feeling drowsy. I don't know why. 29 degrees daytime is telling. So 46 kilometers per hour. No problem. Let's move further. So we are somewhere at this point that, in fact, it's also true that current engineering and advanced project scenario, just depending on certain proclaimed software may not be absolutely assistive to automatically resolve details pertinent various conflicts among various disciplines, and therefore no blind eyes can be allowed to trust communication based before turning. Once we finalize excavation, from whatever way, though it's a very big job, it's a very responsible job, we cannot finalize blindly. We have to go through complete system and see what is required, what's not required, and confirm. And then you have to confirm bearing capacity as well as a part of job. Sometimes it's not given as item, but it's to be done. And when everything is complete, once goes in. We have to stand in our decision. That's another point. We cannot change decision in engineering construction. Changing decision means cost. That point we should keep in mind. So various conflicts may occur, and we have to wait for those to check out. It's very clear that coefficients occur. We can say that as you know, as you can see here, we go for to explain what do I mean, and how much you can receive of that, how much you can depend on that. As many items on various components of whatever project do invite equivalent, additional, or augmentative level of coordination. Let's say as many items on various components of whatever project to invite equivalent, additional, or augmentative level of coordination for all such designs and respective detailing. Applications on site work depend on finally agreed details, which we sometimes name as entitled current documents under proposal, and then approval as such working drawings and also shop drawings, and finals to cover all disciplines in an unified approach, coordination drawings. Very important part it is. It says so much. Whatever you have made decisions, whatever we want to do or whatever we can do, we have more and more opportunities for coordination. And coordination means design coordination within itself as well as design coordination with construction. These are important. You cannot simply say on control. We can start as many items on various components of whatever project to invite equivalent, additional, or augmentative level of coordination for all such designs and respective detailing applications on site. Site work depends on finally agreed details, which we sometimes name or entitle current documents under proposal and then approval as such, working drawings and also shop drawings, and finals to cover all disciplines in an unified approach, coordination drawings. Such activities to produce coordination drawings on various areas of project components do cause professional requirement from various disciplines, and where coordinator has to apply mind fully immersed in an imaginative contemporary ocean of details for that work, keeping abreast applicable specifications and contract related documents, and of course contractual complexities that make entire work compulsory. We have to sit and think about this. Cannot simply run. We have to, contemplate on what is specification, what is design, what is requirement, and what can be better practice than this. If you have better arrangement, the same cost, you should post that. Now, coming on to that point, we say it is really disappointing to note that coordination preference has been found missing among engineers at beginning of professional careers. When one tries or opt to specialize just on its own discipline, even discarding its own branch related other subjects. And it's of course can say necessary for professional to be for sure attain at some specialization level, but simultaneously must move on, move on parallel tracks optimization. We have gone through certain talks on coordination, very certain talks, and it's disappointing ultimately, I can say, it's disappointing to note that coordination preference has been found missing amongst engineers at beginning of professional career when one tries or opt to specialize just on its own discipline. When one tries to opt on discipline, and it's really disappointing to be very frank, we have to be careful about this because coordination is a never ending process and it keeps on continuing at every stage of project from beginning to land. And even from beginning means from designs itself, it's not simply construction I'm talking alone, I'm talking of designs as well. Coordination during design activity is very important, significant, and we have to, because we don't have everything of ourselves, we depend on others. We depend on civil construction for mechanical, construction, a lot of different types of pipe. We cannot miss coordination. That point we have to keep in mind, and that's very important point. So we'll take up this issue later on. It's very important point. We have to move further on this. I'll take leave now for some reason. I'll continue with this. This is a very important chapter, very important talk on coordination, and it's very good for everybody. We cannot miss it in whatever way we think. It cannot be missed, and we have to be simply very realistic about this, and only then we can say we got something done. We cannot miss anything, and that's what is very important point here. And I think